Have you ever wondered, what if LastPass got hacked? Not just a little hack, but what if someone hacked the crown jewels? I read the marketing and saw how LastPass doesn't store your passwords in plain text, but I still had questions. In this video, I'm going to explain how LastPass protects your data so that even if the entire LastPass database was published on the internet, your passwords would still be safe. Let's take a look. Okay, this is going to be mostly a geek speak free presentation, but there is one technical item you do need to understand before any of this will make sense. You need to understand a one-way hash. A one-way hash is an algorithm that takes a piece of data, such as a password, and turns it into a key. Regardless if the piece of data is one character or many characters, it is always the same in length. LastPass uses PBKDF2, password-based key derivation function 2. It's a mouthful. There is a free online tool that helps demonstrate how this works. For simplicity, let's say my password is cat. I run it through the function and it derives the hash key. It's called one way because there isn't a way to take the hash key and run it through a different function to get the result of the cat. I can't take the key you see here and run it through another function to have it return cat. Now I know what you're thinking. Couldn't the bad guys just put a bunch of words through one-way function and create a dictionary of words? Yes, that is true. But this is where it starts to become difficult. The PBKDF2 supports a concept of salt and iterations. A salt helps to make the key unique. In the example above, I have the letter A. If I change it to the letter B, look, an entirely new hash key is generated. Good so far? Let's make it even more complicated and introduce the concept of iterations. You can see each iteration changes the hash key yet again. 2, 3. By default, LastPass uses an iteration of 100,100 rounds. You can see how it would be incredibly difficult to build a database of all the different possibilities for just the word cat. You would need to list out all of the different password combinations, all of the possible salt values, and if that wasn't enough, now you'd have to deal with all of the crazy iteration combinations. You get the idea. When someone says they are using a one-way hash to encrypt your data, you can feel pretty confident that a very unique value is getting generated. So next up, let's take a look at how LastPass uses one-way hashes to help protect your data. Now that we understand hashes, how does LastPass use hashing to store our data safely? LastPass needs to do two things. First, create a unique key for encryption, and second, a way to identify users. All of this is performed without sending the master password to LastPass. So first, it needs to create a unique key to store and unlock our data. LastPass refers to this as the encryption key. It takes your username, password, and the PBKDF2 hash algorithm to create your encryption key. Second, LastPass needs a unique way of identifying us in the system without actually getting a copy of our master password or the encryption key. To do this, it takes username, password, and PBKDF2, but instead of hashing 10,100 times, it iterates to 100,101 times. This is the value it uses to create what it calls the local login hash. To be even more secure and make sure the local login hash can't be identified inside of the LastPass cloud system, when LastPass receives the local login hash, it takes and creates yet another hash. It takes the local login value, applies a new salt unique to each account, and runs it through another hashing algorithm. Once LastPass identifies the person, it can return the encrypted vault back to the user. When the user receives the encrypted vault, it can use the locally stored encryption key and unlock the vault, revealing the password. So now you understand how LastPass works.